Hi friends, welcome back. So in the previous session we have seen the properties of ROC, which are very important. These are the 5 properties you have to remember. The first one is ROC should not contain any pole, and for right side signal ROC is right side to the pole or greater than the pole, and for left side signal ROC is left side to the pole or what we can say less than the pole. And for a finite duration and absolutely integrable signal ROC is entire S-plane, whereas for a two-sided signal ROC is between the two poles but should not contain any pole. That is the first case you have to remember. So ROC should never contain any pole. So if it is in between the poles, and it will never contain that pole, and here this is the pole. That's what we have to select. Okay. So these are the properties of ROC. Now let's enter into the some signals. We have to see what is the Laplace transform and what is the ROC for them. Okay. The first signal what we have to see is delta t. X of t is equal to delta t. What is the Laplace transform? X of s integral minus infinity to infinity delta t e power minus st dt. Okay. So here any function multiplied with delta t, t has to be replaced with 0, then this is going to be 1. So integral minus infinity to infinity delta t dt. Delta t dt. What is this value? Which is nothing but 1. So for delta t, Laplace transform is 1. If I ask what is the ROC for this signal, which is nothing but entire S-plane, you may get doubt. Why entire S-plane? Why can't it be something else? Why it has to be entire S-plane? Because delta t is existing only at 0. That means it is a finite duration signal. So it is not for infinite duration, it is a finite duration. And it is absolutely integrable because the area under the curve is equal to 1. So in that case, I can say it is having ROC entire S-plane. So these are the things you have to remember. Next, U of t. X of t is equal to U of t. For this signal, I have to calculate Laplace transform and ROC. So you tell me. X of s is equal to integral minus infinity to infinity U of t e power minus st dt. To remove this U of t, I have to change the integral limits from 0 to infinity. Then this is going to be integral minus infinity to infinity, 0 to infinity e power minus st dt. So integration for this is e power minus st by minus s 0 to infinity 1 by s. So because of this negative sign, first I will substitute 0, 1. If I substitute infinity, this value is equal to 0. So finally this is nothing but 1 by s. So for U of t, what is the Laplace transform? 1 by s. Then what is the ROC? So can I simply say sigma greater than 0? You may get doubt. Sir, why it is sigma greater than 0? Because see, U of t is a right-sided signal. U of t is a right-sided signal. And what is the pole here? S is equal to 0 is nothing but the pole. So S is equal to 0 is the pole and right-sided signal. So we have to consider the ROC is greater than the pole. So what is the greater than the pole here? Sigma greater than 0. So if I draw this one, ROC, how it look like? Here is the pole at S is equal to 0. So J omega axis, sigma axis. So we have to take ROC in such a way that by omitting this sigma. So this is what the ROC. Clear or not? Take it. Time reversal property. Time reversal property. So here we have to see the properties in terms of Laplace transform as well as ROC. So with this property, what are the changes we are going to get in ROC also? That is also we have to check. So let's say a signal x of t having Laplace transform x of s with ROC is equal to R. With ROC is equal to R. Then for x of minus t, what is the Laplace transform? This is x of minus s. Then what is ROC? ROC is equal to minus R. So you may get doubt, what is this minus R means? Let's say, suppose for example, x of t having ROC sigma greater than, let's say 3, sigma greater than 3. Then what is ROC is equal to minus R? Is it sigma greater than minus 3? No. It is sigma less than minus 3. So this is the one. What is the meaning of it? So minus, that negative sign indicates we have to change the sign. Yes, definitely 3 becomes minus 3. And we have to change the inequality also. That means if it is greater than, we have to take it is less than. That's what the meaning of it. So for example, let's take x of t is equal to u of minus t. Suppose let's say we know u of t. What is the Laplace transform? 1 by s sigma greater than 0. That is ROC. U of minus t. Then this is going to be minus 1 by s because s is replaced with minus s. And sigma 0. If I take minus for 0, it won't make any difference. But I have to change the inequality less than 0. Less than 0. So that means suppose if I take sigma axis, j omega axis, here is the pole 1 by s. Minus 1 by s means pole is equal to 0 only. So 0. I have to take ROC which is less than. Why it is less than? If you observe carefully, u of minus t is a left-sided signal and we are having pole is equal to 0. For a left-sided signal, pole is equal to 0. Then what is ROC? Less than 0. So this is what the ROC except 0. We don't have to consider 0. This is what the ROC is. Clear? Take it. Next property. Exponential multiplication in time domain. Exponential multiplication in time domain. What is this property? Let's see. If a signal x of t having Laplace transform x of s with ROC is equal to R. If this signal x of t is multiplied with exponential e power s naught t x of t. So in the Fourier transform also we have seen exponential multiplication leads to shifting. So here we are going to get x of s minus s naught. Wherever s is there, that has to be replaced with s minus s naught. Then what will happen to ROC? ROC is equal to r plus real part of s naught. R plus real part of s naught. What do you mean by that? Suppose, let's say, I will take one example. E power minus at u of t. For this I have to calculate Laplace transform as well as ROC. Let's first we know u of t. For u of t we know that Laplace transform is equal to 1 by s. And what is the ROC for this? Sigma greater than 0. sigma greater than 0. If it is multiplied with exponential e power minus at u of t, then s minus s naught, if it is positive, but it is minus a, so it has to be s plus a, 1 by s plus a. Here sigma greater than 0 plus real part of minus a, which is nothing but minus a, so that implies sigma greater than minus a. Actually, without knowing the property also, we can say this is the ROC. How, sir? Now if you see sigma axis, j omega axis, what is the pole here? Minus a, so this is the pole minus a, and it is a right sided signal. Why? E power minus at u of t, which is a right sided signal. For a right sided signal, if you know the pole is minus a, then it has to be right side to the minus a, or we can say greater than minus a, so that is nothing but sigma greater than minus a. So this is what the ROC is. This is what the ROC. Clear? Take it. If I take one more example, e power at u of minus t. For this one, we have to calculate Laplace transform as well as ROC. First, let's see what we know. We know e power minus at u of t, just we came to know that it is having Laplace transform is equal to 1 by s plus a. That's okay. And we know here the pole is nothing but minus a, and it is a right sided signal, sigma greater than minus a. That is also okay. Now, if I replace t with minus t, can I get the signal what we require to know? Yes. If I replace t with minus t, then it is e power at u of minus t. Whenever I replace t with minus t, then s has to be replaced with minus s, then 1 by minus s plus a. Or we can write minus 1 by s minus a. If we take minus common out, this is nothing but minus 1 by s minus a. Now here sigma less than a. Sigma less than a. Why, sir? Why it is sigma less than a? So from the property of time reversal, we have to change the sign and we have to change the inequality also. Or directly also we can say, what is the pole here? A. S minus a is equal to 0. S is equal to a. And it is a left sided signal. Pole is a here. Pole is a and it is a left sided signal. So we have to take ROC, which is left side to the pole, or we can say less than the pole. Then we are going to get ROC is nothing but sigma less than a. Sigma less than a. This is what the ROC. Clear? Take it. Let's see one more signal. E power at u of t. E power at u of t. What is the Laplace transform? What is the ROC? We know u of t 1 by s sigma greater than 0. If it is multiplied with e power at, multiplication of exponential property, we have to replace s with s minus a. 1 by s minus a. Sigma greater than minus a. Directly I am writing sigma greater than a. Sorry, not minus a. It is a. Why? What is the pole here? pole is A. And is it a right-sided signal or left-sided signal? It is a right-sided signal. So we have to take ROC, which is the right side to the pole, or we can say greater than the pole. That's why sigma greater than A. So we will take except A, because ROC should never contain any pole. This is what the ROC is. Clear? Take it. One more thing, continuation for this. E power minus AT u of minus t. For this, what is the Laplace transform? What is the ROC? Just now we came to know e power AT u of t 1 by s minus a sigma greater than a. Suppose if I replace t with minus t, then it is going to be e power minus AT u of minus t. Then s has to be replaced with minus s. Then if I take minus common out, this is minus 1 by s plus a sigma less than minus a. Sigma less than minus a. Directly we can say how? Let's take sigma j omega. What is the pole here? Minus a. Minus a is the pole. And if you observe carefully, the given signal is a left-sided signal. So we have to take ROC, which is less than the pole. So this is what the ROC is. This is what the ROC is. Clear? Take it. How to remember? Whenever you see e power minus AT term, then write 1 by s plus a. Whenever you see e power AT term, then just write 1 by s minus a. Now if you observe carefully, what is the pole here? Minus a. Minus a. What is the pole here? Which is plus a. Plus a. From this, can I conclude one thing? In the exponential, the coefficient of t itself is nothing but the pole. That means, to say the pole, we don't have to go for Laplace transform. By seeing the exponential itself, I can say what is the pole. So what is the pole here? This is the pole. This is the pole. These are nothing but the poles. Pole. So I can write the coefficient of t. Coefficient of t. Here in the exponential only. Okay, don't go in any way. Coefficient of t. In exponential. In the exponential. Coefficient of t in the exponential. Next. Depending on whether it is a right-sided signal or left-sided signal, so let's say, if right-sided signal, if it is a right-sided signal, then remember the 2 points here. Whenever the signal is right-sided, the first point is both sides same sign. What is this? You can remember. Both sides same sign. Second one, ROC is right side to the pole. Right side to the pole. What do you mean by that? Let's say e power minus AT u of t. whenever you see e power minus at, you have to write 1 by s plus a. And what do we have to say? Whether we have to say plus sign or minus sign. If you observe here, if it is plus here, then definitely here also plus. If it is minus here, here also it is minus here. That's what the meaning of both sides same sign. Next, what is the pole here? Don't see here, directly see here. Pole is nothing but minus a, right side signal. So sigma greater than minus a. Next, e power at u of t. Then whenever you see e power at, then you have to write 1 by s minus a. Next, what is the pole here? A, and it is the right side signal. So sigma greater than a. Sigma greater than a. So this is the one thing. Next, left sided signal. Whenever you see left sided signal, 2 points you have to remember here also. One is both sides different sign. Both sides different sign. And here ROC is left side to the pole. Left side to the pole. Let's take example. E power minus at u of minus t. For this one, what is the Laplace transform? I told you, whenever you see e power minus at term, then you have to write 1 by s plus a. 1 by s plus a. And do we have to keep a plus sign here or minus sign here? Depending on what sign we are having. So if it is plus here, then we have to take minus here. If it is minus here, then we have to take plus here. So that means both sides a different sign. So it is going to be minus. Is that clear? So once we got this, next, what is the pole here? Minus a, and left side signal sigma less than minus a. Clear? In this way you have to remember. Next, e power at u of minus t. Whenever you see e power at, just you have to write 1 by s minus a, and we have to keep minus sign. Why? Because it is a left side signal. So minus 1 by s minus a. What is the pole here? A, left side signal sigma less than a. So these are the 4 terms you have to remember in this manner only, so that you can understand what is the importance of this method to remember. Clear? Take it. If I ask, inverse Laplace transform of, let's say, 1 by s plus a, what is your answer? What is the inverse Laplace transform of 1 by s plus a? So many people will directly say e power minus at u of t. But is it a correct answer or wrong answer? How can we say? So it may not be, or it may be, maybe may not be. We cannot say it is the correct answer. Why? Because, let's see, for 1 by s plus a, we are going to get 2 answers. E power minus at u of t, definitely. For this one, Laplace transform is this one. What if I say minus e power minus at u of minus t? I told you, whenever you see e power minus at, then it has to be 1 by s plus a. And because it is a left side signal, we have to change the sign. So here it is minus, here it is plus. So we are going to get 2 answers depending on whichever is. Depending on what? Actually, depending on ROC. So if an ROC is not mentioned, we cannot say this is the inverse Laplace transform. So if ROC is mentioned, then only we have to say this is the inverse Laplace transform. This is the inverse Laplace transform if sigma greater than minus A. This is the inverse Laplace transform if sigma less than minus A. So I can say because 1 by S plus A, so which is nothing but having a pole which is at minus A. Minus A means we are having, this is the ROC, or if it is minus A, we are having, this is also ROC. For one pole there exist two ROCs. So which ROC, if it is not mentioned, then we cannot say which is the inverse Laplace transform. If ROC is mentioned, so this is the ROC, then we can write this one. If this is the ROC, then we can write this one. So depending on ROC, we can get exact answer. So can I simply say inverse Laplace transform is not unique? Or we can say inverse Laplace transform is unique if ROC is mentioned. I hope understood. So to get inverse Laplace transform, ROC has to be mentioned. So what is observation? Inverse Laplace transform is uniquely defined if ROC is mentioned. If ROC is mentioned. If ROC is mentioned, then only we can get inverse Laplace transform uniquely. Okay, take it. Which of the following, take down this question, which of the following represent ROC of e power a plus 2t plus 5 u of t? Options: real part of s greater than a plus 2. Option B, real part of s greater than a plus 7. Option C, real part of s greater than a plus 5. Option D, real part of s less than 2. Which one indicates ROC of the given signal? Answer is this one. Because what is the pole here? The coefficient of t. This is the pole. And it is a right side signal. So here the pole, what is the pole? A plus 2. And right side signal. So if it is a pole a plus 2 and right side signal, so real part of s has to be greater than a plus 2. So sigma greater than a plus 2. What is sigma actually? Real part of s greater than a plus 2. Answer is A. Take it. pole is a plus 2. Sir, what is 5? It is simply a constant. Actually, we can write this one as e power 5. This can be written as e power 5 e power a plus 2 into t u of t. So e power 5 is like a constant e power a plus 2 t u of t. So what is the pole here? U of a plus 2 is the only pole. Clear? Next property, which is very important, even though looks very simple, but is not that simple. Linearity property. What is linearity property? Suppose a signal x1 of t having Laplace transform x1 of s with ROC is equal to R1. Another signal x2 of t having Laplace transform x2 of s with ROC is equal to R2. Then if I take a signal a x1 of t plus b x2 of t, then what is the Laplace transform here? A x1 of s plus b x2 of s, b x2 of s. What is the ROC then? R1 intersection R2. It is not R1 plus R2. It is not R1 multiplied with R2. It is R1 intersection with R2. That is nothing but common ROC. That is nothing but common ROC. Common ROC. Okay. So here the students do mistake in this way. What they will do is, whenever Laplace transforms are known, to apply the linearity property, what they will do is, first they will apply the linearity property, then they will try to find out the ROC, which is very wrong answer. Why? What is the sequence we have to do is to apply the linearity property. First, is there a common ROC exist or not? If there exists a common ROC, then only we have to apply the linearity property. Sir, what if there is no common ROC? Then we cannot apply the linearity property, or simply we can say Laplace transform does not exist. So that's what we have to write. So what is the thing? Note point. If R1 intersection R2 is equal to 0, that is no common ROC. Common ROC. That implies Laplace transform does not exist. Does not exist. So if no common ROC, then we can say Laplace transform does not exist. Clear? Take it. Let's take some examples based on the linearity property. Find the Laplace transform and ROC for e power minus t u of t plus e power minus 5t u of t. For this signal, we have to calculate Laplace transform and ROC. Listen carefully. So to apply the linearity property, first we have to check whether the common ROC exists or not. If no common ROC, we can directly say Laplace transform does not exist. We don't have to worry about. So if ROC exists, then only we have to go for the Laplace transform or linearity property. Okay, let's see. For this function, what is the ROC? Right-sided pole is nothing but -1. So sigma greater than -1 here. Right-sided pole is nothing but -5. Sigma greater than -5. Sigma greater than -5. So if I take, let's see, sigma j omega. We are having two poles here. One is at -1, another one is at -5. So for -1, sigma greater than -1. So this is the ROC. This is the ROC. Next, for sigma greater than -5, that means this is the ROC. What is the common ROC? That is nothing but this one. Sigma greater than -1. This is the common ROC we are having. So common ROC existing or not? Yes, definitely common ROC is existing. Then we can apply the Laplace transform here. So what is the Laplace transform? If I apply for this one, 1 by s plus 1. Whenever you see that one, you have to write like this. And for this function, 1 by s plus 5. So finally, s plus 5, s plus 1, 2s plus 6 by s plus 1 into s plus 5. Sigma greater than -1. Sigma greater than -1. Okay. So this is what the Laplace transform. This is the common ROC. Everything is good. So I am having doubt here. Let's say, suppose if this is given, then we can calculate like this Laplace transform. What if Laplace transform is given to you and you have to find out inverse Laplace transform? That means they have given x of s, they want to find out x of t. How we can do that? Sir, we can do the partial fractions. Yes, we can do the partial fractions. Up to this we can get. But here we are having two poles. One is -1, another one is 5, -5. And we are having only one ROC. Now, doubt is, what we have to write this signal? What we have to write this signal as? Is it a right-sided signal or left-sided signal? Is it a right-sided signal or left-sided signal? So for that they have given only one ROC. From that we have to say. So whenever for a number of poles, that means more than one pole is there, and they have given single ROC, that ROC indicates common ROC. The ROC indicates common ROC. So here we are having two poles. Let's say if this is the question they have given, then what we will do? Suppose if this is the question they have given, let's say if x of s is equal to 2s plus 6 by s plus 1 into s plus 5, then find x of t. Find x of t. We have to calculate x of t. So for that what we will do first, and they have given ROC also, sigma greater than -1. So I have to calculate x of t here. So what we can do? First I can apply the partial fractions. Then what we are going to get? 1 by s plus 1 plus 1 by s plus 5. This is what we are going to get. So if I take 0 pattern, so we are having two poles. One is at -1, another one is at -5. One is at -1, another one is at -5. Now for this, they have given only one ROC, which is like this. This is the ROC they have given. Now if you observe carefully, for two poles one ROC is given, that means that is a common ROC. To get this common ROC, what should be the ROC of the two poles? Let's say ROC for this pole may be right side or left side. ROC for this pole may be right side or left side. So to get this common ROC, what should be the ROC? So let's see. For this pole, it has to be right side. For this pole also, it has to be right side. Then only we can get the common ROC. Sir, it is highly difficult to find which one is the right side, which one is the left side. Don't worry. Simply see this. For -1, don't worry about what is the common ROC or something. Just see. For -1, where the ROC given, there is nothing but right side. Next, for -5 also, where the ROC is given, for right side only. So just by saying that, yes, -5 is there, ROC is given, which is right side. So I can say for both the signals, we have to write right side. That means for this one, inverse Laplace transform if I apply, then for this signal also we have to write right side signal. For this signal also we have to write right side signal. Then it is e power minus t u of t plus e power minus 5t u of t. Both are right side signals. So this is the way we have to do it. Clear or not? Take it. So no need to worry. So just see the ROC, where the ROC is present for the given pole. For the pole, right side. For this pole also, it is right side. That's what we have to observe. No need to worry whether it is a common ROC or something like that. So just remember one thing, whether it is present in the right side or left side. These are the things we have to see. Okay, take it.